And let's see what we have here. Okay, so we're going to use polynomial long division to rewrite the expression. All right, I'm going to write it as x cubed minus 3x squared plus no x's plus 2 divided by x minus 3. Now, the question I'm going to ask myself is, we want to know, how do I get x to become x cubed? That's going to be x squared. Multiply x by x squared, and I get x cubed minus 3x squared. I have to subtract down. So that's 0, 0, and then 2. I can't get x to become 2 without some fraction work there, so that's my remainder. And I wrote a plus, but I meant a minus 3. So x squared plus 2 over x minus 3. Now, think about this. Why would that be better in a calculus sense than what I started with? I mean, I can give you reasons, but I want you to think about that. Why would that expression be better? And by that expression, I mean the one on the top, be better than the given expression that we had right in the middle there? You should have some ideas. Oh, look, why would we prefer? So we got to write down what we had, which was x squared plus 2 over x minus 3. Why would I prefer that? Because I can integrate that. I know if I were to integrate this, I'd be like, oh geez, I don't know what to do. But if I were to integrate this, well, I can tell you whose derivative is x squared, and I can tell you whose derivative is 1 over x minus 3, so I can tell you whose derivative is 2 over x minus 3. I don't know if you can. You should be trying to do that right now in your brains. But I can. All right, so another type of thing we got to do. This is related to that previous question. There's a whole bunch of fraction work we're going to be doing. This is a different step, but a similar idea. Okay, solve for a and b. This is actually not calculus. This is algebra 1. So what I'm going to do is I'm going to multiply through everything by x times x minus 3. So I'm going to have 6x plus 6 equals a times x minus 3 plus b times x. So to give you a quick explanation, what just happened is this x minus 3 and this, x times x minus 3 and this other one, those would cancel on the left side. And then if I have a over x, the x's would cancel, but you'd be left with the x minus 3. If you have x minus 3 there, that would cancel with this, so you'd be left with that x. So that's where we got the equation. So now we can write 6x plus 6 equals a plus bx minus 3a. Take a moment, process that. What I did is I distributed this a, and then I undistributed the x. So I factored out the x and grouped things together. Once I've done that, you should be able to notice this. I remember this from like a linear algebra course I did, that 6 is going to be a plus b, and 6 is going to be negative 3a. So the first part of the equation, which I'll underline in pink, is from 6 and a plus b. The second part of the equation, which I'll underline in yellow, is 6 and negative 3a. Well, I could solve for a over here and get negative 2. And then if a were negative 2, b would be 4. That's one way to do it. There's another method you could do from that green line up here. So let's try that. Let's go ahead and shrink this stuff down. And let's write down 6x plus 6. This does not always work. This works if you have kind of these two linear pieces, but if you have fancier pieces, you cannot do this technique, so be careful. What happens if I were to plug in if x equals 3? Then you'd have 18 plus 6, which is 24. 24 equals 3b, and I just realized I made a mistake. I wrote down that b was 4. B is not 4. B is 8. Sorry about that. That's what happens when you do things in your head. Never a good idea. And I realized I made the mistake because right here I get b equals 8. And then I can do the same thing, but plug in a different number. What happens if I plug in 0 for x? Then I'll have 6 equals negative 3a, which means that a is negative 2. Now, I made very intentional choices of 3 and 0. Can you tell me why? I don't know. I hope so. I hope you can figure out why I would pick 3 and why I would pick 0. I'm giving you a moment to process this. You should be thinking about why I would pick 3 and why I would pick 0. I think I just kicked you in the face with that. It's what makes these things equal to 0. So 3 makes this piece equal to 0, which would cancel out your A piece. And 0 makes obviously this piece equal to 0, which would cancel out your B piece. So you can solve for the missing variable. Okay, so we had negative 2 over x plus 8 over x minus 3. Don't forget that. So we had negative 2 over x plus 8 over x minus 3. How does that help us? Well, maybe we want to go ahead and do negative 2 times 1 over x dx plus 8 times 1 over x minus 3 dx. And maybe we understand that one. That's the natural log of x. And then this one's a little bit trickier. You could use substitution if you want, but because there is a 1 in front of the x, it's just 8 times the natural log. Ooh, I should put absolute values there. X minus 3 plus c. Now, if I wanted to, here's a property of logs. You could rewrite this as the natural log of x minus 3 to the 8th over x squared plus c. If you don't remember that property of logs, look it up. See if you can figure out what the heck I just did. Ooh, let's go crazy. So you should try to kind of follow what's going on. So feel free to pause the video and follow what's going on. I'm kind of trying to take this in pieces. This is a little bit of a wacky move. So what's the derivative of the bottom? The derivative of the bottom is 2x minus 4. Can we rewrite the top so it has that derivative? So the top, I want to be 2x minus 4. Well, that's 2x minus 2. So if I put a plus 2 there, that'll be 2x minus 4 plus 2, which is 2x minus 2, which is what we started with, over x squared minus 4x plus 5. Okay, so now take care of the easy part. Okay, so the easy part, that's in quotes, because is it really that easy? I don't know. So the easy part's going to be, let's break this into two integrals. 2x minus 4 over x squared minus 4x plus 5 dx plus 2 over x squared minus 4x plus 5. Now, the thing on the right looks easier. It looks a whole heck of a lot easier, but it's not, because there's not a like u sub thing I could do. So let's go ahead and do that. I'm going to say u equals x squared minus 4x plus 5. So du dx is 2x minus 4, which means that dx is du over 2x minus 4. And let's shrink some things up here. Shrink this up, move this out of the way. That's the difficult part, so really ignore that part. And we're going to have u on the bottom, du over 2x plus 4. That's a minus 4. It just looks like a plus. I might have said plus 4. I don't know what I'm doing anymore. But those will cancel out. So that's 1 over u du. 1 over u du. You should recognize that as that's the natural log of u plus c. So we've done the first part. We have not done the second part. That's the scarier part. Rewrite the bottom using completing the square. Oh, okay. So I have, let's play with that. We got x squared minus 4x. I want that to be like x minus 2 quantity squared. So I need a plus 4. Well, I'll still have this rogue plus 1 because it's a plus 5. So that's going to be 2 over x minus 2 squared plus 1 dx. And now we got to do the calculus. So we got to figure out where that's, okay, so if I think of this as, let's make u equal to x minus 2. That means du is dx. I'm also going to pull the 2 out. So that's 1 over u squared plus 1 du. You should recognize that as an inverse trig derivative. If you're not sure which one, go through and build them. So say, I don't know, y equals the inverse tangent, because that's a favorite of mine, of x, and take the derivative and see what happens. Oh, that's the one that works. So this is 2 times the inverse tangent of u, but u is x minus 2. Technically plus c, but I already had a plus c in the other one. So now we found the antiderivative of both pieces. So the final answer is the natural log of x squared minus 4x plus 5 plus 2 times the inverse tangent of x minus 2 plus c. Whew. Whew. That was crazy and wacky. You could take the derivative there and see if it works, but I bet it does.